So on number 3, when we read part A, it says, find the area of the region bounded below by the x-axis, above by the line y equals 1, on the right by the line x equals 1, and on the left by the curve x equals 1 minus y squared. So I had said to you what they were saying. I already kind of hinted and told you this, but below by the x-axis, so we're not going to go below the x-axis. Above by y equals 1, so we're going to stay below y equals 1. It's bounded on the right by the line x equals 1, which is right here, right? So that's its right boundary, and it's bounded on the left by the parabola. Well, that's going to be this region right here, right? So how are we going to find that region? Well, that's the area between two curves. So yesterday what we talked about is we would draw a strip right in there. Now, the nice thing about that strip is it touches the y equals 1. Every strip you draw in here will touch y equals 1 on top. Every strip you draw will touch the parabola on the bottom, right? So, therefore, the integral of that first part is going to be the top y value, 1, minus the bottom y value. And what is the y value of the parabola?
Positive 1 minus 1.
Say it again, Jesse.
Positive square root of 1 minus x.
Positive square root of 1 minus x. Now, Will, I'm glad you said that, though. When I said, what is the y value of the parabola, you said 1 minus y squared. Now, why is that not the y value of the parabola? What is 1 minus y squared? That's the x value of the parabola, right? And what I said on the video, Skylar, if you remember, is I said what I want you guys to think of when you're looking at this parabola, it's got this equation, right? When I say what is the x value of that parabola, you say 1 minus y squared. Why? Because right here it says x equals 1 minus y squared, right? It says x is equal to 1 minus y squared. So what that means is all of the x coordinates on the parabola are 1 minus y squared. But we don't want the x coordinate of the parabola, right? We want the y coordinate of the parabola because we want this y minus this y. That's what will give us this length. So the y value up here is 1. The y value down here is x. So what do we got to do? We got to solve for y, right? So we have to take this equation, and sometimes on these problems, so I'm going to add the y squared over, subtract the x over there. Then I'm going to take the square root, plus or minus. Now, why is it plus or minus? Top half, bottom half. So I got two different curves here when I'm looking at it that way. Okay? So it's going to be 1 minus the positive square root, so I don't need parentheses, 1 minus x dx. The dx is the width of this strip. 1 minus the square root of 1 minus x is the height of that strip. Height times width gives me the area of that strip, and then what's the integral do? What's the integral do? Adds all the strips together, because the integral comes from sigma, right? The integral adds up all the strips. So, y value 1 minus the y value of the parabola, square root of 1 minus x, that gives me the height, dx is the width. Multiply those, I get the area of a strip. That's the area of one strip right there. The integral adds up all the strips. From the strips will fill the space, or will get added up from 0 to 1. So that's part A. Right? That is the key element that we're talking about here. Now, I'm also making a big deal about, as I'm talking about the strips fill the space, and height times width, and height times width, because you're going to see, and we're going forward here in some other application problems, whenever we set up an integral, it helps to think about it like that. It helps to think of units, and it helps to think what the integrals represent. But then we can just go to our calculator and type that in. Okay, part B says, the area of the region bounded above by the x-axis, below by the line y equals 1, on the right by the line x equals 1, on the left by the curve on the parabola. Well, that's this down here. Above by the x-axis, below by this line here, bounded on the right by y equals 1, and that goes right to this point right here. Okay? Well, that's going to be this little region. Well, I have a feeling it's going to be the same. But it's not going to be the same integral, right? What's going to be the integral? Well, it's going to be this top y value. What's this top y value? Negative square root of 1 minus x minus, what's this y value? Negative 1. Oh, okay. Oh, look at that. It does end up being the same integral, doesn't it? It ends up being 1 minus that. But it's going to be from what to what? Oh, it is going to be the same. Still going to be 0 to 1. The strips are going to go from 0 to 1. So it turns out to be the same integral, but for sure we knew it was going to be the same answer. We knew because of symmetry there and everything that those were going to be equal areas. But they wouldn't always have to be the same exact integral to give the same answer. Okay? And then the last part, in part C, says find the area of the region bounded by the lines x equals 1, y equals 1, and the line. So x equals 1 is this line, y equals 1 is this line, and then this line right here, and since they meet right here, well, that's going to be that triangle. So that's the rest of the space. Well, let's do it. I know it's just a triangle, but let's still do it like a strip. Let's still do it like a top minus bottom. So what is the top curve? What's the top y value? 1 minus the bottom y value. What's the y value of this line? The y value of this line is, we got to solve for y, x minus 2. Now, it's not usually a big deal to solve for y because usually our graphs are given to us solve for y. In this case, they were solved for x. So it's very common in these problems, and especially when you get to your last problems where they had to do some of them, right, with the horizontal strips and some with vertical strips, is you have to rewrite your equations, right? So this y value here is x minus 2. So it's going to be 1 minus, and then we got to do this, dx. And these strips go from where to where? 1, 2, 3. We got to see where they intersect. So the strips fill the space. So the integral is going to add up all the strips from 1, 2, 3. And this is what I was talking about, Will, as far as not needing a calculator. That's going to be 1 minus x plus 2. So that's going to be 3 minus x. That's going to be the integral. You know what I mean? You just do it multi-derivative. Just do it. But I'm okay with you guys typing your calculator. What I want to see is you set up your integrals, add those up. That should be the same answer we got for this region yesterday. But we were able to do it with one integral if we did horizontal strips, right? If we did horizontal strips, the beauty of horizontal strips is every horizontal strip is going to touch the line on the right, the parabola on the left, and so we can just do a right minus left. So let's just review that real quick. What is this? Now here, Skylar, what we said, we want to do this x-coordinate minus that x-coordinate, right? That's how we get that length. So what is this x-coordinate right here? It's the x-coordinate of the line, right? And here it says x equals y plus 2. So this x-coordinate right here is y plus 2. Minus this x-coordinate is what? 1 minus y squared. 1 minus y squared. So this is what we set up yesterday. The width of that strip is dy, delta y. So we got, this is the length of the strip, the width of the strip, delta y, that's the area of the strip. We're going to add up all the strips from -1 to 1, and that will fill the space. -1 to 1. So this one integral would give us this whole area. These three blue integrals would give us that area as well. Should get the same answer, yes.
But if they don't specify which one to use, can you just choose one easier?
That's right. So on our quiz, I may do both. On the quiz, I may do like some of the later problems said where you use horizontal strips or vertical strips, or I might say do both, right? I might say do this problem with horizontal strips and then do it with vertical strips, show that you get the same answer. Or I may give some where I just say find this area, and then you can do whichever you want, right? And sometimes there's one that's clearly easier. And there's going to be some where one of them is virtually impossible. So that's why it's important to learn about the horizontal strips, because there are some where vertical strips may just not even work. Okay, and so horizontal strips would be the way to go. Now, somebody in the other class offered this. I'm going to throw it out there, but I prefer not that you not do it. I mean, as you're working it, you can, but if they want you to draw a sketch and so forth, what this person said is, couldn't you just interchange the x and the y? If I just interchange the x and the y and make this y equals 1 minus x squared, then what I get is I get this parameter, right? And then rewrite this as y equals x plus 2, right? Just interchange the x and the y. Not solve for y, interchange the x and the y, right? Well, what's y equals x plus 2? Well, that is this graph right here. Okay? And then instead of y equals negative 1, do x equals negative 1, which would be right here. And do x equals right here. And look at this region right here. What can you tell me about that region right there? It's the same exact region as my green region, right? So in other words, what you do is you just get an inverse picture, and it's the same region. Well, now what kind of strips would work really good here? Vertical strips would work really good here, right? And so this person had that in. Now, where you can't do that is if in the provinces they give you these as your equations, and they say sketch this region. This is the region you got to sketch, not that. It's a different region. They have the same area, but it's a different region, right? So that doesn't work. But what he was going to do is just interchange those, get it that way, and then that's what you have. I think it's okay to understand that that would give you the same region, but why not just understand you can use horizontal strips and then it works just as well, you know? So I don't know that there's any great advantage to that, and there could be a disadvantage if you graph that as if it was that region. And then did you see the part where I showed on the calculators how you can type in x equals 1 minus y squared and give a relation part? So if you need the calculator to help you with that. All right, so let's talk about 17. So on this, well, okay, 10, so I skipped 10. 10 was just about the units. Are there any of those you want to get questions about? I mean, we can just go through it real quick. They say, what would the integral of f mean? Well, if f was velocity, feet per second, what would the integral be? Net distance, but it's key to not just put feet, but what kind of feet, right? So it'd be net distance traveled, right? Net change in position, right? Not total distance, net distance traveled. Okay, if it was acceleration in feet per second, it's net change in velocity, right? Because acceleration is the rate of change of velocity. So the integral would be the net change in velocity. So again, it's important to say that. I think the word change is good to get in there. Net change in velocity, okay? Just like the other one is net change in feet, right? Net change in distance, okay? I suppose if you said net velocity, it might, that would probably be okay, but all right. So what if F was the rate of water flowing into a tank in liters per minute? The net change in liters, right? The net change in volume of that. And then if F is the slope, then it would just be the change in the y value of the graph. Because really, what is slope? Slope is the rate of change of the y value, right? Slope is the rate of change of the y value. It's how fast it's going up or down, right? It's how fast the y value, the rise, is changing. Okay, so if you want to think of that as a rate, think of slope. We talked about it as a rate, but we haven't really said rate of what. Well, if F is velocity, right? If F is velocity, meters per second, then that's the rate change. That is the change in meters, the top number. Well, when you do slope, the top number is the y, right? So it's a net change in y. So the integral, or it's the rate of change of y. So the integral would be the net change of y, the net amount that the y has changed, right? That's basically what that would be. Just think about it. It's big F of B minus big F of A, right? So it's like the y value, the ending y value minus the beginning y value, right? So it's net change in y would be the thing to say there. Okay, so on 17, we were supposed to do which kind of strips, vertical or horizontal? Vertical, because it says dx, that's the key. When you hear dx, delta x, you have that. Okay, so, okay, so here's 17. So we were supposed to do vertical strips. So vertical strip would go like this. Okay, very simply, the top y value is square root of x, the bottom y value, 0. And I, a lot of times, will write that in there. Top minus, just to remind myself I'm doing top minus bottom. Okay, top minus bottom. Okay, you don't have to have the 0 in there. And then that goes from where to where? 0 to 4. Big. What do you get when you type that in? What do you get? 1630. Okay, number 29, I'm going to skip now. 29 was the same region, right? 29 was the same region, but now you were supposed to do a dy, right? You were supposed to do a dy, which means a horizontal strip. So now we're supposed to do a horizontal strip. Well, what does that mean you have to do with this equation right here? I'm going to have to write that as x equals y squared. Okay? When I'm doing horizontal strips, they have to be in terms of y. So I want this x coordinate, so my integral is going to be right minus left. So it's going to be this x coordinate 4 minus this x coordinate y squared. Okay? And then dy. Totally different looking integral. Totally different looking integral. And then the strips are going to fill this space from where to where? 0 to 2, because this is the point 4, 2. So this is going to fill the space from 0 to 2. And guess what you get? 1630. Okay? We need, this is a very important skill, not just for finding the area between curves. This is an important skill for a lot of the application problems. You'll be surprised on the number of different problems we're going to be doing here already, where we're going to be talking about strips. The strips filling the space, and drawing in your strips, and right minus left, top minus bottom. Okay, happens a lot. Okay, go to this one. So you had a parabola. What was this equation? It was, what's this, 23?
Y minus 2. Y equals 2.
And y squared minus x equals y squared minus 4. And y equals 2 minus x. Okay, so we graph those, we get our region. So the first one we were supposed to do vertical strips. Okay, so what can you tell me you're going to need to do with vertical strips? We're going to have to split it into two, because right here, your vertical strips are going to touch, right, the parabola on the top and on the bottom. But as soon as you get to here, right, as soon as you get to here, it switches. Now your strips are going to touch the line on the top, and they're going to touch the parabola on the bottom. So as soon as the strips are touching a different part of the curve, or a different curve, you've got a new integral that you have to split it up. So we're going to have to go, let's do this first one. So what's this top y value? It's on the parabola. Yeah, we have to solve for this, don't we? So we get x plus 4 equals y squared. We get y equals plus or minus square root of x plus 4. Well, that's the top and the bottom half, right? So the top, so this y value is square root of x plus 4 minus this y value, negative square root x plus 4. Which obviously we could write as 2 square root x plus 4, but you don't have to. You can just leave it just like that. Okay, and then dx. Remember, dx is the width. So what do we got? We got the length of the strip times the width of the strip. That gives us the area of the strip, and then the integral adds up all the strips. And it adds up the strips from -4 to 0. -4 to 0. Plus, what's this y coordinate? 2 minus x. Minus this y coordinate. Dx, and these strips fill the space from, and they go all the way out to 5. I think this is the point 5, negative 3, I think. And you would have to find that, right? You would have to set these two equal to each other somehow, right? You would need to, when you graph them, but really the simple thing would be, well, probably easiest to do this one, x equals 2 minus y. Did they give it to you? They didn't give it to you, did they? So here, if I added the x over here and subtracted, I would have x, and so I would not mess with that square root. So if these are both equal to x, I could just do 2 minus y is equal to y squared minus 4, right? I could just do a solve on that, right? I could solve this one for x and just have 2 minus y is equal to y squared minus 4. And then you would get y equals negative 3. And you'd probably get 0 also. Or no, you'd get 2. I'm sorry, you get 2. So here's the y value of 2 where they intersect. And here's the y value negative 3. And then just put your negative 3 back into here. 2 minus negative 3 would be 2 plus 3, that'd be 5. So that's how we would get this intersection point. So you do have to find those intersection points. And if it's a no calculator, like this could have been a no calculator. So what would you do? Maybe get everything on one side. So you'd have y squared plus y. Let's see, take away 2, that'd be minus 6. So you go y plus 3, y minus 2, right, equals 0. So this, matter of fact, we're going to do one here in a little bit that's a no calculator, right? And so you might have to do this, right? You might have to solve these. And so sure enough, it's going to be at negative 3 and 2. So you're going to get y to be negative 3 and 2. So there's the y equals 2, 1. There's the y equals negative 3. Then plug that back in and get your x. Okay, so very likely you'll have to do this on some no calculator. Now, I think on our quiz for this week, or next week, whatever it is, our next quiz, actually it's going to be a while, but our next quiz, when we do these problems, I'm going to let you use calculator, right? So you're going to use a calculator, graph it, but in the meantime, we're going to be continually working on review packets too. Now, that's one thing about this next quiz in chapter 7. We're not just going to go boom, 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 and do a quiz. We're going to be spreading in review time. Just because I don't want to spend weeks reviewing, I want to mix in new stuff with review. But that's okay. It's still going to be, as we do review stuff, we're going to be reviewing a lot of these things also. So when it comes time for that quiz, it's not going to be a problem. It's not like we're going to forget stuff because we're going to be using it. All right. So anyway, what did we say that went from 0 to 5? Okay, and what did you get on this one? 125 over 6. Okay, and so then when we go to 35, we're supposed to use horizontal strips. The nice thing on this one, this is a nice one for horizontal strips, is because every horizontal strip is going to work. You're going to hit the line on the right, and what was the line? It was y equals x plus 2. No. Y equals 2 minus x. So if we add the x over there and subtract the y, we get x equals 2 minus y, which we're going to need, right? This parabola was what? X equals y squared minus 4. Okay? So the right x coordinate is 2 minus y. So 2 minus y minus the left y coordinate, or excuse me, the left x coordinate, y squared minus 4. dy. I'm fine if you leave it like that. And then those strips fill the space from negative 3 to 2. Negative 3 is down here, 2 is up here. So they fill the space from negative 3 to 2. And you better get the same answer. Okay? So to me, if I was doing this one, horizontal strips would be a great choice because you already got that equation solved for x. This is an easy one to solve for x. You could do it with one integral instead of having to split it up into 2. Okay? All right, we're not going to go on to that. We're going to do some packet work today. Tomorrow's going to be some new stuff again in chapter 7. And then I have to be on Friday, so we'll do some packet work those days as well. All right, so let's get out that 2014 packet. Let's do some work in trying to get finished with that. Okay? Well, I tell you what, before we do that, you can go ahead and get it out. But I've got a problem here that relates to what we were just doing. And I don't remember. Here it is. What's that? It is, well, maybe that's how it works. Okay, this is from their online, and I'm going to be handing this out later. Anyway, but I don't think. Well, wait, is this? This is no calculator. I don't think this is the one I printed. No, this is not the one I printed. This, you know, those midterm review packets. You know, those 4 that we did, like sample 1, sample 2. If you want to leave those at home and not carry them around in your packet, feel free to do that. Because we're probably going to pull those out for a while, right? I mean, there's still a few problems. We need to go back on some of those and probably do and could do. But I am going to be mixing in, so I don't know how much of that we're going to do. So if you want to take those 4 packets and just leave them at home somewhere, or throw them away. I'm not sure I'd throw anything away right now, probably, but you know, that might give you some space because we do have some new packets we're going to be getting over the course of the next 6 weeks. Okay, so the folders might be getting a little full. So those 4 for sure. You know, sample 3, hang on to. But those are yours all. Those all in there. Yeah. So if you want to take those 4 out and take them home and, you know, kind of put them somewhere. It's okay. Because, yeah, I got a stack of problems here. I just ran off some here. I got, you know, some multiple choice. So anyway, but, all right. So this is actually on the AP website because they did kind of make some changes to the curriculum for this year. Not really major changes, but they reworded how they're doing some stuff. And so some of their multiple choice questions are compared to the packets we've been doing, because the packets we've been doing are a number of years old. They're still good, but they've slowly made some shifts to some new types of questions. But to be honest, our book does a pretty good job of asking those types of questions. So we've talked a lot about them throughout the year, so I'm not too worried about it. But I want you to keep seeing them. This isn't one, but this is just one that relates to what we're doing right now. But this is a no calculator, okay? So you got a little bit of algebra work you're going to, and some graphing, some thinking about graphing and what these would look like and stuff. So I would encourage you on this one to sketch those 2 curves as best you can, okay? And think about how you would sketch them. And why would it be important to sketch them? If you want to do the area between them. You got to know top, bottom, right, left, right? You got to know that. So I think getting an idea of kind of what the sketch looks like is kind of important. So work on that one. All right, are you getting the picture? Well, look. So, have you got a sketch? Anybody? Are you still sketching, Max?
Just got the parabola.
How do you get the parabola?
Find the.
I would set it equal to 0 and see where it crosses the x-axis. Right? If you set that parabola equal to 0, because if you find where it crosses the x-axis, then you know symmetry. You know the vertex has to be halfway in between, right? And you can just plot some points and so forth from there. Right? So do that. So set the parabola equal to 0, and you can factor out, what, a 6x? Right? So where's it going to cross? 0 and 3. And you know it faces up, right? You know it's a parabola that faces up. Now, I don't think you have to, you may not need to know where the vertex is, so it doesn't matter. You just know it crosses at 0 and 3, right? Now, what about the line? It crosses at the origin, right? And it's going down. And then, so the next thing is going to be, where does it cross the parabola? Right? Well, how would you do that? Set the two equal to each other. So you know it crosses at the origin. And where else does so they both cross at the origin. And then, where else does a line cross the parabola? Besides the origin. Where? Well, the parabola, we said the parabola crossed at 0, 3, 0 and 3. So doesn't the parabola have to look like this?
Yeah.
Parabola's got to look like that.
It's at 2.
And the line crosses at 0 and has a -6 slope. So the question is, where does it go? Well, I think it crosses over here somewhere, right? And you know that, then it crosses at 2. So let me show you all the algebra work. So there isn't a bit of calculus up on the screen yet, right? Now this is an unusual problem. You know, these multiple choice are supposed to take like 2 minutes each. Well, this is pretty long. Sometimes you get some shorter ones. There's a lot of work to be done. So I set the two equal to each other, and I solved and found where the line crossed the parabola. I set the parabola equal to 0 just to see where it crossed. Now, what do you notice? Don't you have two regions? Right? Notice it did say regions. It said total area. So now you got to do that one. Now you got to do that one. Okay, now you set up your intervals. Now that we know that, now let's set up our integrals, because now we know what's on top and what's on bottom. Because they want to go from 1 to 3. Actually, I actually did that wrong, didn't I? My picture's wrong. Oh, God. Okay, I had too much red there. It should just go right here. So we want that region. We want that region from 1 to 3 is what it says. Okay. Now this part should be easy. I mean, this is to be honest, in this problem, it's funny. See, the calculus is easier than the algebra. In some for some of us, right? I mean, we just haven't done that much. think I got it. Anybody else got it yet? Skylar, you got it? But it's a no calculator, so you're really supposed to do your anti-derivative, plug in your numbers and all that stuff. You got something?
That's right.
Is it one of those choices?
No. That's why I don't know. Right.
Yeah, well, if it's not one of the choices, you're not right. What do you got?
I got 8.
What'd you get for the first section? There's 2 sections, right? You gotta set up 2 integrals. There's an integral from 1 to 2, and there's an integral from 2 to 3. Max, what'd you get? What'd you get for the first section?
Oh wait, never mind. I did not
For
get 8.
the first section, I got 4.
That's what I got. Now my picture obviously is not right? Because the first section, the first section looks bigger than the second section, but that's just, it's not the scale. You got 4 for the first section. I agree. That's what I got.
For the second section, I got 1. I'm running out of room.
Jesse, you got something yet?
No,
What'd you get for the first section, or do you have it done?
You go with B.
You're going to go with it because that's what you got, or you just giving up?
Well, the most commonly accepted test is B.
Says who? That's just something you heard somewhere. Read on.
Like this friend that is like youth group or small group that is in grade. He does like ACT prep for kids in Colorado. And
Right.
the average boost when you take his class is like 6 on your ACT. And every year he takes, like every test he takes the ACT, he gets a
the first time I did it, I made life a lot harder on myself as I didn't simplify when I did the two curves subtracted. So I got 4 for that first section. You're redoing the second section, okay. Did you actually get 8 for the second section then? Is that why you're saying B?
Yeah.
Oh, yeah, I got B too.
Yeah. See, you did the same thing I did as you do the first time that you didn't combine these, which just gives you more calculation review. It's not a big deal. I mean, it still should come out.
I looked the first time I just I got B. I put 9 times 6 as 63.
Yeah.
So I have -9 minus the -8. I was confused. There's no negative area.
Oh, yeah.
That's what should redid that.
So top minus bottom, in the first section, the line is on top, so negative. Now, I went ahead and distributed. That's the other thing. You gotta make sure you distribute that negative, right? You gotta distribute that negative. So if you do the line, -6x minus the parabola, it'd be minus 6x squared plus 18x. So you gotta make sure to distribute that. And then you combine these x's, that'd be 12x minus 6x squared. You don't have to combine them. But then you gotta do your antiderivative. We just haven't practiced that antiderivative that much, so I thought it was worthwhile to do. So you raise it up to 2, divide by 2, 6x squared, raise it up to 3, divide by 3, that's 2x cubed. From 1 to 2, put in your 2, put in your 1, you get 4 for that first section. Then it's the other way around, 6x squared minus 18x minus -6, which would be plus 6x. Combine those to minus 12x, and do your antiderivative, then 2 to 3. I got 8. That's a doozy. I mean, for like I said, the multiple choice, I don't know what we've been working on that, 15, 20 minutes. The multiple choice is supposed to be 2 minutes per question, right? To me, I've said this before on test taking strategy is you get one like this, especially early in the test. Only question number 7. To me, I'm going to start that one and I'm going to go, oh man, this is going to take a while. I know what to do. It's going to take a while. I would mark that and I would come back, right? Because what I would not want to do, because sometimes people are like, I know what to do. I'm going to do this one and I'm going to spend my time in it. But then if you might run out of time to do 3 easy ones at the end that you could have done. It's better to get the 3 easy ones and lose this one that you're not going to have time for than to spend too much time on just this one. So I would mark it, and then I would go through and make sure I read the rest of the questions and had time to, because this is the section that probably is the most time pressure. Okay? This is like 28 questions, 55 minutes. Actually, on the EP test, it's going to be 30 questions and 60 minutes. But it's the most time pressure. And so that's the one where you want to make sure that you get through and get a chance to read, because some of the ones at the end might be pretty easy. And, so, hey, I know what to do on this one. What I do on ones where I had no idea what to do, put an X, and then those would be the last ones I come through if I have time. If it's one I know how to do, I might circle it, or whatever, circle it, and then make sure I read through the rest of the questions, then come back and circle ones and then spend my time. That's
Are there like any tricks to speed that question up?
not really. I mean, do more in your head. You know what I mean? I think again, it just depends how comfortable you are with it. I mean, like right away when I looked at this one, because I've done enough of these, I thought, okay, this is going to cross at 0 and 3. So right away I had a good idea of the parabola. The line, -6x, took a little more time to see where they crossed, but I had an idea. It wasn't, you can get the slope, but because here's what I did for the line. So my question on the line is it going to cross? Where's it going to go? Well, what's the slope? Well, the slope of the line is -6. What's the slope of this? Well, I just did the derivative real quick. I had 12x minus 18. I put in 0, right? Because right at the origin, I knew they crossed at 0. So 12x minus 18, put in 0, get -18. So I knew that the parabola had a -18 slope, and the line only had -6. So I knew this was going a lot steeper than the line. So I knew the line was going to come through like this. And so then I saw, so that took a little bit of time to find out. But once I had that, once you imagine that without even drawing it, I knew, okay, the line's going to be above. But then I did have to find where so I wouldn't have to write out every single thing there to get that. So that would have saved some time. But again, and that's what I've said to you before. You know, it's not like you have to be an algebra whiz all the time. But man, the better you are at the algebra, the more you know your trig values, the more it just helps, right? Because sometimes you get so bogged down in the algebra that you just give up because you're just like, oh my God, I can't even get this algebra. So you don't even get to the calculus part. So anyway, all right. So let's just look at this. So let's say you would skip, right? So let's say you didn't spend too much time on this, so you could get to some of the laterals. Now this goes all the way out to 28. Okay. So let's look at one right now. That looks like it might take a little time. But here's one that's 2 from the end. Now, what do you think right away when you see that? Do what? Split. What do you mean split up? Not split up. Oh, come on. Factor, algebra. Yeah. Right away. Algebra. Oh. That's not going to work. Is it? Whoa. Oh. Well, never mind. I was thinking that was going to be a short. I was looking for something short and kind of a little bit easy. Well, what of all the things we learned, what's our only option? I think I heard somebody say. Maybe you just not split it. It's a U substitution. But what would we let U equal? The bottom. Yeah. I was. Yeah. Well, this is not a bad one to review real quick either. Let U be the bottom because what's that do? Well, the du is just going to be what? 2. Where do you get the 2?
Oh, it's just dx.
So just dx, right? So now, what we were saying about that? So that takes care of that, and the dx is just going to be a du. But then you got all this stuff. What do you do with that?
Rearrange.
So u minus 2 is x. So you're going to have u minus 2 squared. See, I was hoping to find out that it didn't have a lot of algebra. Yeah, but we're going to take more time. So look what you end up with on top. You're going to have u squared minus 4u plus 4 minus u plus 2 minus 5, right? So that's going to be u squared minus 5u minus.
Plus 6 minus 5.
Oh, I forgot the 2. Plus 1, right? And now split it up. So now you're going to have u minus 5 plus 1 over u, right? So that's 1/2 u squared minus 5u plus ln u. Now you got a choice. You can either go back to your x's, right? Let's do that. X plus 2 squared minus 5 times x plus 2 plus ln x plus 2. And then we put in our 2 1. Put in your 2. Oh, jeez. So I was hoping this would be 16. What's that? 8. Put in your 2 there is 4. That's minus 20. Put in your 2 there is plus ln 4. Minus, now put in our 1. 3 squared, that's 9 halves. 1 plus 3 is 3. Times 5 is minus 15. Plus ln 3. So 8 minus 20 is negative 16. Plus 15. 8 minus 20 is negative 12, thank you. Negative 12, that's going to be plus 15. So that's 3, and then minus 4.5. So 3 minus 4.5. Negative 1.5. Ooh. Right away, I'm thinking there. But, you're right. And then it's going to be ln 4 minus ln 3. What's ln 4 minus ln 3? That's ln 4/3. But you're right. As soon as you got that negative 3 halves, you're thinking, okay, plus I got this ln. Yeah, that's definitely going there. Oh, okay. Well, so much for my point. I was going to try to make a point here.
It's just not hard test.
You get one.
The middle has to be, there has to be at least a stretch.
God, no kid. And there's one of those volume ones we can't do. That's one we haven't learned how to do yet.
We'd be screwed if we took this thing.
Aha! An easy one.
You just want.
If H is, well, we should be able to do though. I mean, but H is, so what's H prime of 1? Well, before you do H prime of 1, you need H prime of X. So F prime of G of X times G prime of X. So you put a 1 in, F prime G of 1, which again, you wouldn't have to write out all this. Right? G prime of 1 is negative 2. G of 1 is 3, so that'd be F prime of 3. F prime of 3 is 7, so 7 times negative 2. Aha! 30 seconds. God, save myself some time. Jeez.
We spent 30 minutes on the first part.
I know.
That's
Good. Yeah, no, that,
27 questions.
yeah, we got the rest of the time. Okay, here's a good limit. We're gonna work on some other stuff here. Here's a limit problem. Okay, so what's the first thing you do when you get a limit problem? Well, remember we have those special limit problems? If it looks like f of x plus h minus f of x all over h, right? Then it's not really a limit problem, it's really what? Derivative, right? You do derivative, but does this look like that? This doesn't look like that. So, when you get a limit problem like that, what's the first thing you do? Plug in a 3. Tangent of 0 is 0 because it's sine over cosine, right? So that'd be 0 over 1. And then plug in a 3 here. E to the 0 is 1. 3 times 1 is 3. Minus 3, that's 0. You get 0 over 0, what do? Keep going. So you've got some choices. What do you mean keep going? Do algebra, like factor whatever. Or our favorite Frenchman? Huh? L'Hopital. Do the derivative of the top, derivative of the bottom. What's the derivative of tangent? Secant squared. Times derivative inside, which is 1. What's the derivative of e to the x minus 3? Just the e to the x minus 3 minus 1. So now we can put a 3 in there, we get secant of 0. Now remember, that's secant of 0 squared, and remember, that's cosine, right? Secant squared is 1 over cosine squared. What's cosine of 0? 1. So the top is 1. What about here? 3 minus 3 is 0. E to the 0 is 1. 3 times 1 is 3. 3 minus 1. Right. L'Hopital's rule would be the way to go. Because there really is no algebra or anything we can do, right? We did some factoring. We did some stuff like that. But I think you get 0 over 0. L'Hopital's rule is usually the way to go. Usually the way to go. Okay? That was that one we said we could do. Okay, anyway, I had you get out that 2014 packet, so let's do that right now. 2014. Okay, so let's go through and let's see what we haven't done, because we're basically going to finish this packet for tomorrow. Yeah. So we've done all of one, right? We've done all of one. Okay. We've done part C of 2, and we can't do the other 2 parts, right? Yeah. So we'll wait on those. Okay. We did all of 3. How much of 4 did we do? Part C. Okay, so we're going to finish 4. So make a note to yourself. We'll finish number 4. We did all of 5. Okay, and let's look at 6. So we can do part A and B. We can't do C. So let's go to 6 and do A and B. That's not very much. So let's finish 4 and let's do the first 2 parts of 6.